Hello and welcome to another Dante tutorial. In this video, I'll show you how to use the Ansys Restart Analysis feature to model different loading conditions for a press quench simulation. The Ansys Restart feature allows you to restart a simulation from a specific load step that you saved the results for. This means that we can adjust boundary conditions in specific steps without having to rerun the entire model. Currently, restart analysis only works for static structural, transient structural, and coupled thermal stress analysis. We'll begin with the press quench example here that I copied over from the Dante installation directory. Inside our press quench example, we have a mechanical model, which holds our part geometry, the carburization model, which we use to generate the carbon profile, and the thermal model, which we use to generate the temperature history. In this video, however, we're only going to be focusing on the stress model here. So I'm going to double click the setup here and open up the stress model. Once we have the stress model open, we can take a look at the different boundary conditions. In this model, we have an axisymmetric ring geometry, a top die, a bottom die, and an expander. If we take a look at the loads in our model tree, remote force 1 here applied to the expander, we have a 100 Newton force applied to both the expander and top die during the press quench step, which is step 4. You'll notice that a 5 Newton force is also applied during the other steps, and the reason for this is so that the tooling does not separate from the part, which will make emergence a little bit easier. The bottom die, however, if we look at remote displacement 3, is just fixed in place and no force is applied. Before we can change the restart controls and the different restart options, the next thing we'll want to make sure is that we have the correct carbon profile mapped in. This is especially important if you copied over the example from our installation directory. So to do that, if we go to C/M profile and click on the path here, this will open up a Windows dialog box where we can select the correct carbon profile. For me, the correct carbon profile is inside the working directory inside the Dante_files. It is this CBN file here. So I can select this and click open, and this should load in the correct carbon profile for my computer. Once we change the carbon profile path, we can take a look at the restart controls located inside the analysis settings here. In the analysis settings details tab, we can scroll down and expand the restart controls. By default, the generate restart points is set to program controlled. We'll want to change this to manual, which will give us the load step and substep option. This way, we can personally select what load step and what substep that we want to save the result files for. The result files will be used as the restart file for all future models. For the load step here, I'm going to select all and leave substep as last, which means that this will save the result files for the last substep for every load step. Once we have those options selected, the next thing we want to do before we can solve the model is go to our Dante tab here, go to Dante model, select stress, and finalize our model settings. Once we finalize our model settings and you see a green check mark, we can go back to the Home tab and click Solve. Since this is a small model, this should only take a few minutes. And after this model is done solving, we can take a look at the different files we have and the Dante results down here. After the model is finished running, we can take a look at some of the different results. Since we use the Dante package, we can see the different phase volume fractions, including austenite, ferrite, pearlite, upper and lower bainite, as well as martensite. The Dante results also include the total hardness and the carbon profile that we mapped in from our carburizing model. We'll also want to keep an eye on the distortion, which is shown here, in terms of the x direction and y direction, which is affected by the press quench parameters, the different loading conditions that we applied. So these will be important once we start changing the loading conditions in our future restart models. Another thing we can see is if we right-click Solution, we can open up the Solver Files directory and take a look at what files are generated. For a restart analysis, we should have a file.rst, the .rdb file, and the LDHI file. This means that our restart controls were successfully input and that we can use this for any future restart models that we build. To build the restart file, first we'll have to go to Workbench and duplicate the stress model that we just ran. We can do this by right-clicking and clicking Duplicate. This way, we don't have to re-import our geometry or redefine any boundary conditions. Once we've duplicated the stress model, we can double-click Setup and open up the static structural window. Once the window opens, the first thing that we'll want to do is go to the Dante tab here, click on Stress, and click on the stress model. Next, what we'll want to do is delete the C/M profile because we're going to be importing it from the restart file that we generated previously. If we leave the C/M profile here, this means that the carbon will get reddened twice, which would cause an error inside the Dante subroutines. Once we deleted the carbon profile, we have to click Finalize Model Settings so that this saves. Next, we can go to the solution tree by clicking Solution, go into the Solution tab here, and click Read Results From and By Copy. This should open up the working directory for this model, but we'll want to go to the working directory for the model that we just ran, which is inside our DP0, sys3, mechanical, and select the file.rst from here. Now this should give us an option of what units we want. We can leave this as selected because Ansys automatically reads this from the .rst file that we selected. At this point, if we take a look at the results again, this should match what we just ran from our previous model. Now, since we want to restart from press quench step and change the loads, we want to go to Analysis Settings here, and we should see an option called Restart Analysis at the very top. So again, instead of Restart Type, instead of Program Controlled, we'll want to change this to Manual. For the current restart point, we save the results for every step for the last substep. Since the press is activated during the third step, as you can see here, activated from the end time of 3611 to 3612, we'll want to start from the last substep of step 2. So we can select load step 2 and substep 28 here. And now we can change our different remote forces to change the loading condition during the press quench step. So now if we go to remote force 1, instead of 100 newtons, we can double this to 200 for the expander. And instead of negative 100 for the top die, we'll do negative 200 and negative 200. Now that we changed the loading condition, all we have to do is right-click Solution and rerun the analysis. So once the restart model has finished running, what we can do is compare the results between the two different models. The right model here is the restart model where we changed the load to 200 newtons during the press quench step, and the left model here is the original model with the 100 newton load. In both models, we can take a look at the carbon profile, the hardness, and the different phase volume fractions. So these results should be the exact same between both models because we didn't change any thermal boundary conditions and it uses the same temperature history. The only change that we made between these two models is the loading during the press quench step. This means that if we look at the distortion, in this case, it's in terms of the x direction, which is radial, you'll notice a difference between the two different models. So here, with the 100 newton load, we see a distortion of 0.084 millimeters in the radial direction, but for the 200 newton load, we actually see a larger distortion of 0.12 millimeters. If we look at the y direction vertically, we actually see a smaller distortion here for the new 200 newton load model at 0.024 millimeters, but the original model has a distortion of 0.04 millimeters. Another thing we can look at is inside the solution information here. So if you scroll all the way to the bottom of the solver output file, we'll notice that the restart model, although we only restarted from the second step, still saved us a little bit more time compared to the original model. For larger models and for models with more steps, using restart is a very good way to save modeling time for any large models. Thanks for watching this tutorial on how to use the restart analysis in Ansys. If you have any more questions or are interested in learning more about the Dante software, you can visit our website at www.dante-solutions.com or email us at support@dante-solutions.com.